Good morning, ladies and gentlemen. Today we're on page 103 of your student journal, and our objective or our goal is today I will use multiple strategies to find the LCM, period. Okay. So we do have some new vocabulary. We've already talked about what prime numbers are, and yesterday we listed the smallest prime numbers, and we said they're 2, 3, 5, 7, 11, and 13. Our new vocabulary word today is least common multiple. So it's the smallest number other than 1 that is a multiple shared by 2 or more numbers. So the least common multiple of 24 and 36. So the multiples of 24 are just multiplying 24. That's why it's called multiples. So 1 times 24 is 24. 2 times 24 is 48. 3 times 24 is 72. And then the multiples of 36 is the same. I always start with 1. So 36 times 1 is 36. 36 times 2 is 72. Now, what I find then is the smallest, the least, or the smallest one they have in common is 72. Now, when we found factors, we always find the greatest common factor. We never find the least common factor because the least common factor will always be 1. Now the reason when we do multiples, we don't find the greatest common multiple is because it would be infinite, because numbers go on infinitely. So this one we're looking for the least common multiple. Okay, so we're going to use a couple strategies. One strategy we already know is the ladder method. We're just going to change it a little bit for the least common multiple. But our strategy is similar. We're going to write the numbers, we're going to draw the L, and then this is where it gets different. When we use the ladder for the greatest common factor, we only multiplied this side. Notice here for least common multiple, we're going to do an L and we're going to multiply everything on the bottom. That's where it's going to be different. Another strategy that we could just use is listing of multiples. So we're going to be doing both of those and see which one works best for you. So we're going to list the multiples out as well. Sometimes this one's a little bit trickier though. Okay, so what does this actually look like? And I think you'll see quickly which method you prefer for this one. Okay, so find the LCM of 12 and 16. So I'm going to start with my ladder method, and I'm just going to do my ladder for 12 and 16. So I start with my prime numbers, and 2 works. So I can divide both by 2 and I get 6 and 8. And then 2 will work again, and I'll get 3 and 4. And then nothing works. 2 doesn't work and 3 doesn't work. So what I have here is I need to multiply out the L. So I have 2 times 2 times 3 times 4. So what do I get? I can do it in groups. I can say 2 times 2 is 4, 3 times 4 is 12, and 4 times 12 is 48. So that is the least common multiple using the ladder method. The other method I could use is just listing out the multiples. So I could say 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48, 12 times 5 is 60. I usually try and do about 5. 16 times 1 is 16, 16 times 2 is 32, and 16 times 3 is 48. Now if you're not really strong with your multiplication facts, this strategy might be harder for you. So I saw the least one that I came up with was 48. It was the first time they had one in common. Okay, let's look at my next one. It says, find the LCM of 12 and 28. So if I'm going to use the ladder method, I'm going to start with 2 because it works. So I can get 6 and 14. I could do 2 again and get 3 and 7. And nothing will work for 3 and 7. So I just need to multiply out all of those. So 2 times 2 times 3 times 7. So I get 4 times 21 equals 84. So 84 works. Now, watch what happens if I try the other strategy. This is why this strategy gets really hard. So 12 times 1 is 12, times 2 is 24, times 3 is 36, 48, and 60. 28, 28, 56. And then I'm kind of stuck because I don't really know that. So I could try and add 28 to this, and if I added 28 to that, I would get 84. Okay, so then maybe I'd have to go back to this one and try more. So 60, so I could say 12 times 6 is 72, 12 times 8 is 84. But this one's a little bit trickier for this unless you know your facts really well. Okay, let's look at our next problem. It says 2 friends are running laps. Eric completes a lap in 30 minutes, and Fernando completes a lap in 45 minutes. If they started together at the same time, in how many minutes will they be together at the starting line again? Okay, so this is looking for when will they meet up. So when's their multiple going to meet? So the ladder method, okay, 30 can be divided by 2, but 45 won't, but 3 can work, and I get 10 and 15. 2 will work, but not for 15. 3 won't work. 5 will work though, and I get 2 and 3, and that's the best I can get. So then let's multiply those out, and I'm running out of room. So 3 times 5 times 2 times 3. So we can say 15 times 6 equals 90. So at 90 minutes, they'll run into each other, which makes sense because Eric will have completed 3 laps and Fernando will have completed 2 laps. I'm not going to do the other strategy for that one just because I don't have, well, I can actually squeeze in room. So 30 times 45. So 30 times 1 is 30. 30 times 2 is 60. 30 times 3 is 90. 45 times 1 is 45, and 45 times 2 is 90. So that's where it comes, this strategy as well. Okay, so let's try some together. We're on page 104. And our first problem says 21 and 35. So let's try our ladder method. 21 and 35. Okay, well 2 won't work, 3 will work, but not for there. 5 won't work, 7 will work on both. So let's divide both by 7 and we get 3 and 5. And nothing else will work because 2 won't work and 3 won't work. So let's multiply those all together. 7 times 3 times 5 is 21 times 5, which is 105. Okay, if we did the other strategy, what would we get? We'd have to do our multiplication table. So 21 times 1 is 21, 42, 63, 84, and 105. And 35 would be 35, 70, and 105. So both strategies, I get the same answer. Okay, let's try 14 and 21. So 2 is a factor, but not there. 3 is not a factor, 5 is not a factor, 7 will work. And then nothing else will work. So we have 7 times 2 times 3, which is 14 times 3, which is 42. Okay, and if we did the other strategy, we would have got the same answer. So 14 times 1 is 14, 14 times 2 is 28, and 14 times 3 is 42. 21 times 1 is 21, and 22 times 2 is 42. So again, both strategies will work. Okay, let's look at our word problem. Joe is buying school supplies to donate to a school. Pencils come in packs of 24 and erasers come in packs of 36. Assuming that Joe has to buy complete packs, and if he wants to have the same number of pencils and erasers, what is the least number of pencils and erasers he could buy? Okay, so let's set it up, 24 and 36. So 2 is a factor of both those, so we can get 12 and 18. 2 is also a factor of those, so we can get 6 and 9. 2 is not a factor of both those, but 3 is. So then we can get 2 and 3, and then nothing else can happen. So let's multiply all those out. So we get 2 times 2 times 3 times 2 times 3. So we get 4 times 6 times 3. So we get 24 times 3. Wow, so we get 72 is the first one. So 72. So they would need to have, 72 is our first multiple, so he would need to buy 3 packs of pencils. I don't really have room. So 3 pencils, and then he would have to just buy 2 packs of erasers, and he would have enough. Okay, so ladies and gentlemen, you're going to be doing some pages on your own. Use what strategy works best for you. Have a great day.